The National Electrical Code, or NEC, does not mandate that the motor overload switch must be placed specifically between the motor starter coil and neutral, as depicted in NEC Handbook Exhibit 430.17. The positioning of the overload switch is contingent upon the particular application it serves and the directions provided by the manufacturer of the equipment. The National Electrical Code provides guidelines for motor protection, and these guidelines include the use of overload protection devices. Overload protection is intended to protect the motor and its associated circuitry from damage due to excessive current draw. The NEC stipulates that overload protection devices should be selected and installed in accordance with their listing and labeling. This means that the manufacturer's instructions are paramount in determining how the overload switch should be integrated into the motor control circuit. Several factors influence the optimal location of the overload switch. Firstly, the type of motor starter being used plays a role. There are different types of motor starters, such as across-the-line starters, reduced voltage starters, and variable frequency drives. Each type of starter may have specific requirements for the placement of the overload switch. Secondly, the voltage level of the motor circuit is a consideration. Motors can operate at various voltage levels, such as 120 volts, 208 volts, 240 volts, 480 volts, or even higher. The voltage level will affect the selection of the overload switch and its proper placement in the circuit. Thirdly, the full load current of the motor is a crucial factor. The full load current, or FLO, is the amount of current the motor draws when operating at its rated horsepower and voltage. The overload switch must be sized appropriately to protect the motor from overcurrent conditions based on its FLA. Fourthly, the ambient temperature in which the motor and control circuit are located can impact the performance of the overload switch. High ambient temperatures can cause the overload switch to trip prematurely, while low temperatures may affect its responsiveness. Therefore, temperature compensation features may be necessary in certain applications. The manufacturer's instructions for the overload switch will typically specify the recommended wiring configuration and the acceptable range of ambient temperatures. Fifthly, the presence of other control devices in the motor circuit can influence the placement of the overload switch. For instance, if the circuit includes a start-stop push-button station, a selector switch, or a programmable logic controller, or PLC, the overload switch must be integrated in a way that ensures proper operation of the entire control system. The NEC provides guidelines for motor control circuits in Article 430. These guidelines cover various aspects of motor protection, including overload protection, short-circuit protection, and ground fault protection. Section 430.73 specifically addresses the overload protection requirements for motors. It states that each motor shall be protected against overload by an overload device that is responsive to motor current. The overload device shall be selected to trip at not more than a specified percentage of the motor's full load current. The percentage varies depending on the type of motor and its service factor. The NEC also permits the use of thermal overload relays, which are commonly used in motor starters. Thermal overload relays contain a heating element that is heated by the motor current. When the current exceeds a certain level, the heating element causes the relay to trip, disconnecting the motor from the power supply. The location of the overload switch in relation to the motor starter coil is not explicitly dictated by the NEC. The NEC provides flexibility in the design of motor control circuits, allowing engineers and electricians to choose the configuration that best suits the application. However, it is essential to ensure that the chosen configuration meets all applicable safety requirements and provides adequate protection for the motor and the circuit. In some cases, placing the overload switch between the motor starter coil and neutral may be a convenient and effective way to implement overload protection. This configuration can simplify the wiring and reduce the number of components required. However, it is not the only acceptable configuration, and other arrangements may be more appropriate in certain situations. For example, in some applications, it may be preferable to place the overload switch in the motor's power supply line upstream of the motor starter. This configuration can provide additional protection against short circuits and ground faults. Ultimately, the decision of where to place the overload switch should be based on a thorough understanding of the NEC requirements, the manufacturer's instructions, and the specific characteristics of the motor and its control circuit. It is crucial to consult with qualified electrical professionals to ensure that the chosen configuration meets all applicable safety standards and provides reliable protection for the motor and the electrical system. When designing a motor control circuit, it is important to consider the following factors. Firstly, the type of motor being used. Different types of motors, such as induction motors, synchronous motors, and direct current motors, have different characteristics and require different types of protection. Secondly, the operating environment of the motor. Motors operating in harsh environments, such as those with high temperatures, high humidity, or corrosive atmospheres, may require special overload protection devices. Thirdly, the load characteristics of the motor. Motors that are subjected to frequent starting and stopping or to sudden changes in load may require overload protection devices with special features such as inverse time characteristics or adjustable trip settings. Fourthly, the coordination of overload protection with other protective devices in the electrical system. The overload protection devices should be coordinated with the short-circuit protection devices and the ground fault protection devices to ensure that the entire system is adequately protected. In addition to the NEC, other standards and regulations may also apply to motor control circuits. These may include standards from organizations such as the National Electrical Manufacturers Association, or NEMA, the Institute of Electrical and Electronics Engineers, or IEE, and Underwriters Laboratories, or ALL. It is important to be familiar with all applicable standards and regulations when designing and installing motor control circuits. The NEC Handbook provides additional information and guidance on the application of the NEC requirements. The handbook includes examples, illustrations, and explanations that can help clarify the intent of the code and provide practical solutions to common electrical problems. The NEC Handbook is a valuable resource for electrical professionals who are involved in the design, installation, and maintenance of electrical systems. In summary, the NEC does not mandate a specific location for the motor overload switch in relation to the motor starter coil and neutral. The location is determined by the application, the manufacturer's instructions, and the overall design of the motor control circuit. It is essential to comply with all applicable NEC requirements and to consult with qualified electrical professionals to ensure that the motor and the electrical system are adequately protected. The selection and placement of the overload switch must be carefully considered to ensure that it provides reliable protection against overcurrent conditions and that it does not interfere with the proper operation of the motor control circuit. By following these guidelines, you can ensure that your motor control circuits are safe, reliable, and compliant with all applicable standards and regulations. Remember to always prioritize safety when working with electricity and to consult with qualified professionals if you have any questions or concerns.